So what if I told you that the reason the Earth has a solid iron core is exactly the same mathematical reason that a waterfall creates swirling eddies?
I mean, it sounds like a massive stretch when you put it exactly that way.
Right, well, and the exact same reason your body is built out of stable carbon atoms.
Yeah, you were talking about geology, fluid dynamics, and quantum chemistry.
Mhm.
In our everyday experience, those are just completely different worlds.
Exactly. Usually when we talk about learning a new subject, there is this expectation of strict boundaries,
Hmm.
like a map, you know?
Right, a very compartmentalized map.
Yeah, you cross a border and the rules of the terrain change, the language changes, and the map explicitly tells you that you are here and not over there.
Which makes sense pragmatically. I mean, it is
Wow.
how we organize universities.
Totally. We keep biology in one silo, physics in another, earth sciences in a third.
It is how we keep from being completely overwhelmed by the sheer complexity of the universe, really.
But then you step back. And as someone who loves to learn, and if you are listening to this right now, I know you are exactly that kind of person, you start reading across these different fields.
And suddenly those borders just kind of dissolve.
They dissolve completely. You start looking at the structural landscape of reality, and you realize it isn't compartmentalized at all.
Right, it is entirely unified.
Yes, it is unified. You start seeing the identical shapes and the identical rules echoing across wildly different scales of existence. And today we are looking at the ultimate pattern.
We really are. We are looking at what might literally be the foundational structural blueprint for reality itself.
Because today's deep dive is centered on a massive and frankly mind-bending stack of theoretical physics documents. They cover what is called universal shell structures and the architecture of symmetry.
It is dense material, but it is incredibly rewarding.
Oh, for sure. And I want to set our mission for you right up front. Our goal today isn't to just learn some isolated quantum mechanics or a bit of astrophysics.
That's not the point.
The mission is to uncover a hidden universal mathematical backbone that dictates exactly why the universe organizes itself the way it does.
From the microscopic quantum realm all the way up to the churning of galaxies.
Okay, let's unpack this, because the core thesis of these documents totally upended how I see the world.
It is a major paradigm shift. The key shift we have to make today is how we actually view symmetry.
Because normally we think of symmetry as just a passive description, right? Like a snowflake looks the same on both sides.
Right, or a butterfly's wings mirroring each other.
Yeah.
But the documents we are analyzing today treat symmetry as an active evolutionary structural force.
An active force.
Yes, it is the architecture of possibility. It dictates what can and cannot physically exist.
Okay, so the authors argue that shell structures like layers, concentric spheres, nesting layers are not some localized physical
No,
accident.
they aren't just rocks settling or particles randomly clumping together.
They are a universal geometric property of three-dimensional rotational symmetry.
Exactly. The documents provide this massive cross-domain catalog showing that whether you are looking at an atom, a planet, or the chaotic turbulence of a fluid, they are all governed by the exact same mathematical engine.
So what is the actual term for that mathematical engine?
It is called the SO3 rotation group.
SO3. Okay, break that down for me.
SO3 essentially describes all the possible ways you can smoothly rotate an object in three-dimensional space while keeping its center fixed.
So it's just spinning a ball in place.
Exactly. Now, whenever you have a physical system with approximate spherical symmetry, meaning it looks roughly the same in all directions,
Right.
and you apply some kind of confining inward pulling force to it, the mathematics of that system automatically fractures into two distinct parts.
Okay, wait. A system with spherical symmetry and a confining force. Give me a physical example so I can actually picture this fracturing.
Well, think of a star. It is roughly a sphere, and gravity is the confining force pulling all that plasma inward toward the center.
Okay, I can picture that. Gravity crushing it inwards.
Right. When you try to calculate the physics of that star, the math naturally separates. You get a radial part.
Radial meaning from the center out.
Yes, the radial part dictates the in and out layers, the distance from the center. And then you get an angular part.
And what does the angular part do?
The angular part dictates the shapes and behaviors on the surface of those specific radial layers.
Okay, the text refers to the specific math governing this as the spherical Laplacian.
Yes, the spherical Laplacian.
I mean, I know what a sphere is, but what on earth is a Laplacian? How does one piece of math create layers in a giant star and layers in a tiny atom?
Let's avoid the dense calculus here.
Yeah.
Just think of the spherical Laplacian as the universe's ultimate stress tester for anything round.
A stress tester.
Right.
Okay.
Mathematically, it is an operator. An operator is just a set of instructions. It takes a physical state and measures how much it curves or how much it vibrates.
Or how much energy it holds.
Right. And because of the pure, unadulterated geometry of three-dimensional space, this instruction manual always produces two things.
Which are?
First, the radial instructions produce nodes. These are places where the energy zeroes out, which physically manifest as hard boundary layers.
So those are the actual shells.
Exactly, the shells. And second, the angular instructions produce what we call spherical harmonics.
Spherical harmonics, so like patterns on a sphere.
Precisely. Imagine a vibrating bell. It doesn't just vibrate as one solid mass, right?
Right, it has ripples.
Ripples travel across its surface, creating complex standing wave patterns.
Yeah.
Some parts of the bell move a lot, and some parts stay perfectly still.
Oh, so spherical harmonics are the 3D equivalent of those vibration patterns.
Yes, they dictate the modes of energy that can stably exist on each of those radial shells.
Wow. So it is like having a master blueprint for a Russian nesting doll.
That is a great analogy.
But depending on the universe you are operating in, you build it out of different materials. In one domain, you build the nesting doll out of solid matter, like the geologic layers of a planet. In another, you build it out of quantum probability waves, like the orbitals of an atom. And in another, out of pure math space, like the turbulence in a fluid.
That is a highly accurate way to visualize it. The matter or the probability wave is just the domain-specific physics.
It is a local building material.
Exactly. But the blueprint, the Russian nesting doll structure itself, is a purely geometric inheritance from the SO3 rotational symmetry of our 3D space.
The documents actually categorize these phenomena into 3 universal shell types based on the specific building material being used.
They do. This is a very systematic breakdown.
Right. Let's look at those 3 types, because this cross-domain catalog is where the theory really proves its point. The first one is type I, which they call eigenmode shells.
Yes, type I shells are discrete, stable, quantized states. This is the realm of quantum mechanics.
So we are talking about atoms here.
Atoms, exactly. In an atom, the confining radial force isn't gravity. It is the Coulomb force.
Meaning the electromagnetic pole of the positive nucleus grabbing onto the negative electrons?
Right. And the mathematical stress tester here is the Schrödinger equation. When you apply the spherical Laplacian to the Schrödinger equation, it spits out perfectly discrete, separated electron shells and subshells.
Meaning the electrons just can't orbit wherever they want?
No, they cannot. They are locked into these specific quantized nesting dolls.
Exactly. It's a fully closed system, right?
Fully closed. The energy levels are locked in and completely stable. An electron is either in shell 1 or shell 2.
It cannot be in shell 1.5.
Exactly. There is no in-between.
Okay, well, that is the microscopic world. But then the document scales up massively to type 2 thermodynamic shells.
This is where we look at the macroscopic scale.
And I have to push back here for a second. You were saying that the Earth's mantle and a quantum electron cloud are doing the exact same thing.
Mathematically, yes.
But one is made of physical magma and rock being crushed by gravity, and the other is just a ghostly wave of quantum probability. How can pure geometry override actual, tangible physical forces?
Well, it doesn't override them. It orchestrates them. In type 2 thermodynamic shells, we leave the quantum realm entirely.
So we are dealing with macroscopic bodies, planets and stars.
Yes. And the confining force here is hydrostatic equilibrium. That is the epic battle between gravity trying to crush a star inward and thermal pressure trying to blow it outward.
So gravity pulls and pressure pushes.
Right. But when you solve the equations for that macroscopic thermodynamic battle using the spherical Laplacian, the math does the exact same thing it did for the atom.
It creates nodes.
It creates nodes. It naturally forms layered equilibrium zones. In a red giant star, this manifests as thermonuclear stratification.
Meaning different layers are burning different fuels.
Exactly. You get a dense helium core surrounded by a shell where helium is actively burning, surrounded by another shell where hydrogen is burning.
And what about the Earth? Does this apply to planets too?
The Earth is the exact same geometric principle applied to rock and metal.
So an inner solid iron core, an outer liquid core, a highly viscous mantle, and a thin, rocky crust.
Yes, they are thermodynamic shells dictated by temperature, pressure, and material density.
But the mathematics of their radial stability boundaries, the reason they settle into distinct concentric spheres instead of just a perfectly smooth gradient, is identical to the quantum shell.
Identical. The geometry provides the scaffolding, and the local physics just fills it in.
That is just staggering to me. The atomic subshell and the Earth's mantle are mathematically siblings.
They are structurally related, yes.
Which brings us to the third one, and honestly the one that gave me the most trouble reading through this, type 3. Spectral shells.
Ah, yes, the fluid dynamics section.
The documents mention fluid turbulence cascades. Whenever I think of turbulence, I just think of absolute chaos. Spilled milk spreading in a puddle, smoke swirling from a fire.
Or air shaking an airplane.
Yeah, exactly. How does absolute messy chaos have a pristine shell structure?
This is where it requires a bit of an abstract leap. In fluid dynamics, which is governed by the Navier-Stokes equations, the shell structure doesn't exist in physical space.
Wait, it doesn't exist in physical space?
No. You can't slice open a turbulent waterfall and physically measure the distance between shell layers with a ruler.
So where do these shells exist?
These shells exist in what physicists call K-space or Fourier space.
Yeah, if you are listening while driving right now, don't worry, we aren't going to leave you hanging on Fourier space.
Yeah.
I need a concrete mechanism here because K-space just sounds like science fiction.
Let's use an analogy. Think of Fourier space, like a massive music equalizer on a soundboard.
Okay, an equalizer.
When you listen to a symphony, your ear hears one unified, messy sound wave. But a sound engineer looks at the equalizer and they don't see the physical instruments.
Right, they see bars jumping up and down at different frequencies.
Exactly. They see the bass notes operating at low frequencies, the midtones in the middle, and the treble at the high frequencies. The equalizer decomposes the messy reality into distinct layers of frequency.
Okay, I follow that. The equalizer strips away the physical sound wave and just shows me the energy at different frequency bands.
Right. Now apply that to a turbulent waterfall. Instead of looking at the physical drops of water, you apply a Fourier transform.
So you put the waterfall through an equalizer.
Yes, and what you are measuring is the kinetic energy of the swirling eddies. In turbulence, energy is usually injected at a large scale.
So like giant, slow-moving whirlpools.
Yes, those are your bass notes. But those big whirlpools are unstable. They break apart into medium-sized eddies.
And midtones.
And those break down into tiny, microscopic, fast-spinning eddies, the treble notes.
Where the kinetic energy finally dissipates into heat.
Right. And if you map that transfer of energy from the giant eddies down to the microscopic ones, you find that the energy doesn't just slosh around randomly.
It has a structure.
It cascades across spherical shells in spectral space. The energy distributes over distinct layers of constant wave number.
So it is a transient flowing energy flux.
Yes. But mathematically, that energy decomposes using the exact same spherical harmonics, the exact same geometric blueprint as the electron in the atom and the magma in the planet.
So even pure chaos is forced to organize itself into Russian nesting dolls of energy. That is incredible.
It is the universal reach of SO3 symmetry.
But all right, let's stop and look at the actual numbers here. Because if this blueprint is exactly the same, if this SO3 rotational geometry is truly universal, why are the actual shell capacities completely different?
What do you mean by capacities specifically?
Well, I remember high school chemistry. An atomic electron shell holds specific numbers of electrons, right?
Right, they have fixed limits.
Shell 1 holds 2, shell 2 holds 8, then 18. But the source material notes that a nuclear shell, the protons and neutrons clustered inside the center of that very same atom, has entirely different capacities.
Yes, they do.
The text calls them magic numbers, and they are 2, 8, 20, 28, 50. How can the geometric blueprint be identical if the final capacities of the nesting dolls are so different?
That is the pivotal question of the entire first half of this deep dive. And it leads us directly to the mathematical engine that is actually running this whole system.
Right.
The 2L+1 degeneracy law.
The 2L+1 degeneracy law. I highlighted this heavily in my notes. Let's get into this because this feels like the master key to everything we've talked about so far.
It is the master key. We established that SO3 is the rotation group of our 3D space. And its most profound physical consequence is this universal degeneracy law.
Now, in physics, degeneracy doesn't mean something is breaking down, right?
No, not at all.
Yeah.
It simply refers to the number of independent states or spatial orientations that share the exact same energy level.
So like different parking spots that all cost the exact same amount to park in?
Good analogy. The law states that for any given angular degree, which physicists denote with the letter L, there are exactly 2L+1 independent spatial orientations available.
Okay, let's walk through that mathematical ladder step by step because I want to build a periodic table from pure geometry.
Let's do it. We start at the bottom of the ladder. When your angular degree L is 0, we call this a monopole.
Okay, a monopole.
Geometrically, it is a perfect, featureless sphere. Now plug L equals 0 into our formula. 2 times 0 plus 1, what do you get? Exactly. There is only one state. Think of a perfectly blank cue ball.
Okay.
No matter how you spin it, no matter how you look at it, it always looks exactly the same. There is only one independent way to orient a perfect sphere in 3D space.
Okay, so step 1 is a 1. Let's climb.
Yeah.
Step 2, where L equals 1.
We call this a dipole. It is no longer a smooth sphere.
Yeah.
Imagine a figure 8 or a dumbbell shape.
All right.
Plug L equals 1 into the formula. 2 times 1 plus 1, you get 3.
Right. And I can picture that. If I have a dumbbell, I can point it up and down. That's 1 orientation. I can
Yeah.
point it left and right. That's 2. Or I can point it forward and backward. That's 3, the X, Y, and Z axis.
Precisely. 3 independent spatial orientations for the dipole. Let's keep climbing. L equals 2.
So 2 times 2 plus 1 is 5.
This is a quadrupole.
Yeah.
The shape gets more complex, kind of like a 4-leaf clover, and there are exactly 5 independent ways to orient that specific shape in 3D space without them overlapping.
And if we go to L equals 3 in octupole,
It is an even more complex 8-lobed shape. 2 times 3 plus 1 gives you exactly 7 states.
so the pure geometric ladder of states in our universe is just the sequence of odd numbers, 1, 3, 5, 7, 9.
Yes. That integer ladder is the fundamental geometric inheritance of existing in 3-dimensional space.
Wow.
Now let's apply this to your atomic shells to answer your question about chemistry. In an atom, electrons fill up these available geometric states. But electrons possess a bizarre quantum property called spin.
They spin like tiny tops.
Not physically, but mathematically, yes. And an electron spin can only point in 2 directions, up or down.
Okay.
Because of this, every single geometric parking spot we just calculated can actually hold 2 electrons, 1 spin up and 1 spin down.
Oh, okay. So to find the capacity of the atomic shells, we take our geometric ladder and just multiply it by 2.
Yes. Walk through the math.
Let me do the math on this because seeing this click is wild. For the very first atomic shell, the lowest energy level, you just have the simplest shape, the monopole,
Right. L equals 0.
which gave us 1 state. We multiply that by 2 for the electron spin. So the first shell holds exactly 2 electrons.
Which is exactly why the first row of the periodic table only has hydrogen and helium.
Wow. Okay, shell number 2. Now we have slightly more energy, so we have room for the monopole A and D, the dipole.
Right.
1 state plus 3 states equals 4 total states. I multiply by 2 for spin, and I get 8 electrons.
Keep going.
Third shell, we have the quadrupole. Monopole is 1, dipole is 3, quadrupole is 5. 1 plus 3 plus 5 is 9 states. Multiply by 2 for spin is 18 electrons.
And the fourth shell?
The fourth shell would add the octupole's 7 states, making 16 total states. Times 2 is 32.
So 2, 8, 18, 32.
I remember memorizing that exact sequence in high school chemistry. They called it the Tekken squared rule.
Yes, the Bohr model, essentially.
And I always just thought, well, that's just chemistry. That's just a random rule of nature. But what this document proves is that the periodic table of elements isn't arbitrary chemistry at all.
It is dictated entirely by geometry.
By the pure geometry of a 3D sphere. The 1, 3, 5, 7 sequence gives us the shape of the entire chemical universe.
It does. It dictates why carbon bonds the way it does, why noble gases are inert, why metals conduct electricity. It is all just 3D geometry finding its resting states.
Amazing.
But you ask why the nucleus has different numbers. Why the magic numbers of 2, 8, 20, 28, 50, 82, and 126?
Right. Because if the proton is sitting in the exact same 3D space as the electron, shouldn't it follow the exact same 2, 8, 18, 32 capacity limits?
You would think so, but the protons and neutrons inside the nucleus are governed by a completely different set of physical forces.
Oh.
Remember, the geometry is the blueprint, but the local forces determine how you build the house. The electron is pulled by electromagnetism. But the protons and neutrons are governed by the strong nuclear force.
And the strong force is different.
Very different. It includes an incredibly violent dynamic called strong spin-orbit coupling.
Spin-orbit coupling. Okay, break that down for me. That sounds like the quantum spin of the particle is interacting with its physical orbit around the center of the nucleus.
That is exactly what it is. Think of the atom as a calm solar system. The planets, the electrons, spin on their axes and they orbit the sun.
Right.
But the spin of the planet doesn't really affect its giant orbit, that is weak spin-orbit coupling. But the nucleus...
The nucleus is different.
The nucleus is not a calm solar system. It is a hyperdense, chaotic mosh pit. In the nucleus, the intrinsic spin of a proton interacts violently with its orbital momentum. They grab onto each other.
So they get tangled up.
Intimately tangled.
Yeah.
The orbital angular momentum, which is our L, and the spin strongly couple together.
Okay.
And they create a brand new combined total angular momentum, which physicists call J.
So J is the new tangled version.
Right, and the formula becomes that J equals L plus or minus 1/2.
So wait, in the electron cloud, the 1, 3, 5, 7 ladder stays clean and pristine. But in the nucleus, This violent strong force takes that beautiful ladder and just warps it.
It completely shatters the clean order of the ladder. The strong interaction acts like a massive magnetic twist.
Wow.
It pulls certain high-energy orbital levels drastically down and pushes other low-energy levels drastically up. The parking spots are still there, but the order in which they are filled gets completely scrambled.
So shell number 3 might suddenly steal parking spots from shell number 4.
Exactly. Because of this massive reordering, the actual shell closures, the points where a nuclear shell is totally full, perfectly round and stable, happen at different aggregate numbers.
Hence the 2, 8, 20, 28, 50 sequence.
Yes, those are the stable plateaus in the scrambled nuclear mosh pit.
But are the fundamental building blocks still the same?
They are mathematically identical. The new degeneracy formula for these scrambled total angular momentum levels is 2J plus 1.
Ah, 2J plus 1.
If you look at the math, it is completely 100% derived from the exact same SO3 rotational algebra. The nucleus isn't inventing new mass.
It doesn't have a different blueprint.
No, it is just taking the 3D spherical ladder and applying a massive energetic twist to it. The underlying geometric alphabet remains identical.
Okay, this is a massive aha moment for me, and I hope it is for everyone listening, because we are seeing the ultimate unification here.
It's deeply unifying.
Whether we are talking about the electron shells dictating the biology of our bodies, or the magic numbers dictating nuclear radiation, or the seismic waves propagating through the Earth's mantle.
Well, the turbulence in a jet engine.
Yes, they are all just expressions of three-dimensional space organizing itself.
Which is a beautiful unifying thought.
It is, but it raises a massive glaring question, one that the source documents actually spent a lot of time on.
Why 3D?
Yes, why 3D? Why does this specific 3D geometry govern our reality? I mean, look, we have height, width, and depth, 3 dimensions.
Right.
Did the universe just get lucky? Could all of this organized beauty have existed in a 4-dimensional universe or a 2-dimensional one?
It is one of the deepest questions in physics. And the source material tackles this head-on with an analysis of dimensional stability.
Oh, I loved this part.
They propose that 3-dimensional space is not a coincidence. It is not a random roll of the cosmic dice. 3D space is a stability optimum. It is the ultimate mathematical Goldilocks dimension for hierarchical organization.
The Goldilocks dimension. Not too hot, not too cold. Let's evaluate this, because the text goes into something called angular crowding analysis, testing how these rules operate in different dimensions.
It is a fascinating thought experiment.
And if you are listening to this, get ready to stretch your imagination, because we have to picture universes that don't even exist. Let's start by evaluating a hypothetical 2D universe. Flightland.
Imagine a universe drawn on a piece of infinitely thin paper. You have height and width, but absolutely zero depth.
Okay.
The rotation group there is no longer SO3, it is SO2. You can only rotate things like a steering wheel on that flat plane.
Right. And what happens to our math engine in Flatland? Does the 2L plus 1 ladder still work?
It completely breaks down. In 2 dimensions, the number of independent angular modes is a constant 2.
A constant 2.
Yes. For every single energy level, there are only 2 states. There is no growing ladder of complexity.
So there is no 1, 3, 5, 7 sequence. Just 2, 2, 2, 2.
Exactly. And because of that constant flat multiplicity, 2D space is geometrically under-resolved.
Under-resolved, what does that mean physically?
It means it does not possess enough angular richness or enough spatial vocabulary to enclose a true volume. Physical systems in 2D cannot form stable volumetric shells. They can only form flat rings.
So no nesting dolls, just flat hula hoops.
Right. And you cannot build complex nested hierarchical structures.
Yeah.
You can't build complex chemistry atoms or living biological cells. All you have are flat, unlayered rings.
That makes sense.
2D space is simply too sparse. It lacks the degrees of freedom required to build complexity.
Okay, that makes intuitive sense. 2D is too simple. But let's go the other way. What if we jump into 4D space or 5D?
Higher dimensions.
Yeah, because more dimensions means more room.
Right.
You have an entire extra axis of movement. Shouldn't more room be inherently better for building massive, complex, layered things?
You would naturally assume so. If you have more space, you can build bigger structures. But the math reveals the exact opposite.
Really?
When you move to 4 dimensions, the rotation group becomes SO4, and the number of independent angular modes doesn't grow cleanly like our 1, 3, 5, 7 ladder.
How does it grow?
It grows superlinearly. In 4D, the multiplicity grows proportionally to L plus 1 squared.
Okay, let me do that math. For the lowest state, L equals 0, it is 1. For L equals 1, the dipole equivalent 1 plus 1 squared is 4.
Right.
For L equals 2, it is 9. For L equals 3, it is 16. So the ladder in a four-dimensional universe is 1, 4, 9, 16, 25. It is growing way faster than our 3D ladder.
It is growing explosively. And in physics, this explosive geometric growth causes a catastrophic fatal problem called spectral crowding.
Spectral crowding. I tried to come up with an analogy for this when reading the notes.
Let's hear it.
It is kind of like an old-school radio tuner. In our 3D universe, the radio stations, the energy modes, are spaced out nicely. 1, 3, 5, 7.
You have clear channels.
Yeah, you turn the dial to station 3 and the music is clear. You turn it to 5 and it's clear. But in a 4D universe, it is 1, 4, 9, 16, 25. By the time you get to slightly higher energy levels, there are just too many stations broadcasting.
Exactly.
And they are all squeezed into the exact same frequency space. When you turn the dial, you don't hear a clear song, you just get chaotic, overlapping noise.
That analogy is mathematically spot on. In 4D and above, there are simply too many competing directions for energy to go.
It's too crowded.
If you try to build a stable atom in 4D, the energy of the electron spreads across all these dozens of available overlapping modes. The stability required to maintain a discrete boundary is completely destroyed.
So the electron would just sort of dissolve into all those extra dimensions?
Essentially, yes. You cannot have a stable, hierarchical Russian nesting doll structure if the energy is constantly bleeding out into a dozen extra orthogonal directions.
Wow.
The mode competition is too fierce. It prevents any stable equilibrium from forming. Planets wouldn't hold together. Atoms wouldn't form shells. Complexity is impossible because stability is impossible.
So 2D is a barren wasteland of flat rings. 4D is an overcrowded, chaotic mess of bleeding energy.
And 3D is the balanced closure regime.
The Goldilocks zone.
Yes. The multiplicity grows perfectly linearly, 2L plus 1. It provides exactly enough angular richness to build complex volumetric patterns, true shells that can enclose an interior naturally.
Then it restricts the mode competition.
Exactly. It restricts it just enough to allow those energetic structures to remain stable over billions of years. This specific dimension beautifully and uniquely balances richness with restriction.
That is staggering to think about. 3D isn't just what we are used to. It is the mathematical pinnacle of structural stability.
It is unique.
But wait, this leads to an even crazier thought. If 3D is this perfect mathematical sweet spot, this absolute stability optimum, how did we get here?
That is the ultimate question.
Did space itself just happen to pop into existence perfectly balanced at exactly 3,000 dimensions?
This is where we cross from established physics into the most deeply theoretical and, frankly, mind-bending part of the source material.
I was waiting for this part.
The authors introduce something called primordial pi closure. And I warn you, this framework stops describing the universe as it is today and starts theorizing about how dimensionality itself might have evolved.
Yeah, I had to read this section 3 times. They introduced the concept of d equals pi 3.14159, the ratio of a circle's circumference to its diameter. But they are using it as a dimension.
Yes, they are.
Hold on. How can you have pi dimensions? I mean, I can picture a 2D square. I can picture a 3D cube. I can even sort of mathematically imagine a 4D hypercube. But what on earth is a 3.14-dimensional object?
It is a great question, and to understand it, we have to talk about fractal dimensions.
Fractal dimensions. Okay.
Think of a coastline like the coast of Britain. If you measure it with a kilometer-long stick, you get one length. But if you measure with a 1-meter stick, you catch all the little inlets and rocks, and the length gets much longer.
Because you are measuring more of the jagged edges.
Exactly. It is too jagged and complex to be a simple 1D line, but it doesn't fill up a whole 2D plane like a solid square. So mathematically, a coastline has a fractal dimension, somewhere between 1 and 2.
Okay, so fractional dimensions exist as a measure of complex, wrinkly, non-smooth reality.
Exactly. The authors of the paper treat dimension not as a strict locked integer like 1, 2, or 3, but as a continuous variable that could be evaluated algebraically.
And they can do math on that.
Yes, it is a mathematical technique called analytic continuation. They take the formula for shell multiplicity, the very formula that gave us the radio stations, and they plug in d equals pi.
And what happens when you build a theoretical universe in exactly pi dimensions?
The math reveals a primordial coherence curvature equilibrium. In a pi-dimensional space, the angular multiplicity doesn't grow linearly like L to the power of 1 in 3D.
Right.
And it doesn't grow explosively like L to the power of 2 in 4D. When you do the analytic continuation at d equals pi, it grows at exactly L to the power of 1.14159.
So it is hovering right in between linear and explosive.
It creates a pre-stable tension-bearing regime. It is slightly richer and slightly more crowded than our neat 3D space, but it is not totally chaotic and destructive like 4D space.
It is tense.
Yes. The theory proposes a wild idea that the universe initially emerged at this pi equilibrium. It was a raw, tense, wrinkly, pre-stable state of reality.
Okay, but look around. We clearly don't live in a pi-dimensional universe today. We live in a pristine, perfectly linear 3D one. How do we get from a chaotic 3.14 to a stable 3?
Through a mathematical mechanism they term the closure projection, or mathematically the projection of pi to 3.
And what does that projection actually do?
The theory suggests the universe stabilized itself by mathematically stripping away that excess exponent, the pi minus 3 surplus.
It just shed it.
It shed this primordial geometric tension, smoothing out the fractal wrinkles to project down into the perfectly balanced linear 3D regime.
So if you are listening to this, whether you are at the gym or making dinner, let me try to frame what this actually implies, because it is dizzying.
It changes everything.
Space wasn't just an empty, pre-built wooden box waiting for matter to be poured into it. Dimensionality itself evolved. Space had to find its own structural balance.
Exactly.
It started in a state of wrinkly mathematical tension, and it literally bled off fractional dimensions until it snapped into exactly 3 dimensions.
Because 3D was the unique, stable geometric attractor for reality.
And it had to do this before a single atom or planet or star could even exist.
That is the profound implication of the paper. The 2L+1 law isn't just a geometric accident of the box we happen to live in. It is the stabilized resolution point of the entire cosmos. The universe cooled into 3D the same way water freezes into a perfectly structured snowflake.
Okay, my brain needs a second to cool down too. Space evolved to find structural balance. But if space evolved to find a balanced closure, did symmetry itself evolve?
Right.
Are there higher ladders of math that the universe is trying to climb? This leads directly into the second half of the documents, what they call the exceptional hierarchy of structural number.
Oh, yes, the symmetry ladder.
We are talking about a very specific set of numbers here: 2, 3, 8, and 24.
These numbers 2, 3, 8, 24 are incredibly famous in advanced mathematics. And I want to be very clear here, this is not numerology.
Right, this isn't some mystical, arbitrary counting game.
Not at all. The authors describe these numbers as structural attractors. They represent successive evolutionary thresholds where mathematics itself becomes exactly constrained, rigid, globally organized, and highly generative.
It is an evolutionary ladder of symmetry closure.
Exactly.
The symmetry ladder. Let's climb it step by step. Level 1 is binary closure, the number 2.
2 represents the emergence of polarity. It is the absolute simplest form of organization, the very concept of left and right, positive and negative chirality.
You cannot have structure without difference.
Exactly. In quantum physics, this bedrock level, the number 2, is represented by something quite deep, the spinorial double cover of rotations.
Okay, spinorial double cover. You are going to have to unpack that heavily for us. What is a spinor and why is it doubling anything?
Let's use an analogy. In our macroscopic classical world, if you have a coffee cup and you turn it 360 degrees on the table, it is exactly back where it started, right?
Right. 1 full rotation equals a reset.
But quantum mechanics revealed that fundamental particles like electrons don't rotate like classical coffee cups.
They don't.
No, they possess intrinsic quantum spin. And the mathematics required to describe that quantum spin isn't our old friend SO3, it is a deeper, stranger group called SU2.
SU2, and how does that behave?
In the math of SU2, if you rotate an electron 360 degrees, it doesn't go back to normal. It actually arrives perfectly upside down or phase shifted.
Wait, a full circle leaves it upside down?
Yes, you have to rotate the electron 720 degrees, 2 full circles, to get it back to its original starting state.
That is mind-bending.
That is the double cover. The quantum world requires twice the rotational space as the physical world.
That is wild. And SU2 fundamentally relies on 2-component objects.
Yes, those objects are called spinors. A spinor is a 2-component mathematical object. The true quantum representation of 3D rotation relies fundamentally on this binary 2-component nature.
So it is the absolute foundation.
It tells us that before you can even have the concept of a 3D spatial rotation, you must first have the deeper binary concept of quantum polarity. SU2 acts as the algebraic interior to simple, rigid body motion.
So the number 2 is the absolute quantum bedrock. Then we move up the ladder to level 2, rotational closure, the number 3.
3 is the dimension of ordinary macroscopic spatial rotational freedom. It gives us the three angular momentum generators we experience every day, moving around the x-axis, the y-axis, and the z-axis.
The physical world.
Geometrically, it gives us the S-squared sphere, the standard 2D surface of a 3D ball.
This is the 3D space we just spent all that time proving was the stability optimum. It gives us the 2L+1 stable angular modes that build the periodic table.
Exactly. But what is deeply important here mathematically is that level 1, the number 2, and level 2, the number 3, are intimately, inextricably entangled.
How so?
You can't truly separate them. The algebraic group SU2, our binary quantum spinor group, is geometrically identical to a three-dimensional sphere known as S cubed.
Let me stop you. SU2 is a three-sphere.
Yeah.
So our normal 3D vector rotation secretly points upward into a higher, hidden spherical geometry.
Yes. The mathematics of fundamental quantum spin and the mathematics of classical 3D space are two faces of the exact same geometric coin. They are locked together.
There is an arithmetic mnemonic in the source material right here that I absolutely loved because it bridges us perfectly to the next level of the ladder.
I know exactly the one you mean.
In our 3D rotational math, the first non-trivial shape is the dipole L equals 1, which gives us 3 spatial states. The next shape is the quadrupole L equals 2, which gives us 5 states.
Right.
If you take those two foundational geometric building blocks and add them together, 3 plus 5, you get 8.
It is beautifully nested, isn't it? The first two non-trivial rotational sectors in 3D physics natively sum to the first exceptional algebraic dimension, which is 8.
Which is level 3 on the symmetry ladder. Exceptional algebraic closure. The number 8, what happens to the math when we hit this 8-dimensional bottleneck of constraint?
We enter the realm of the octonions.
Sounds like an alien race.
They kind of act like one, honestly. In all of mathematics, there are only 4 normed division algebra.
And a division algebra is exactly.
Division algebra is simply a number system where you can add, subtract, multiply, and divide without breaking the fundamental rules of arithmetic.
Okay, what are the 4?
First, you have the real numbers, a 1D line, normal everyday math. Then you have the complex numbers, a 2D plane introducing imaginary numbers.
Right.
Third, you have the quaternions, a 4D math system used heavily to calculate 3D rotations in video games and spacecraft.
And the 4th.
And finally, the fourth system is the octonions, which operate in 8 dimensions.
And then it just stops. There is no 16-dimensional division algebra or 32.
It completely definitively stops. The mathematical theorem was proven in the 20th century. The octonions are the final possible system.
Wow.
But they come with a massive catch. As you move up these systems, you lose mathematical properties. Complex numbers lose the ability to easily say which number is bigger. Quaternions lose commutativity.
Meaning A times B no longer equals B times A.
Exactly. But the octonions, they introduce non-associativity.
Non-associativity. I know the word, but what does it mean in practice?
It means that if you have 3 numbers, the order in which you group them fundamentally changes the result.
Really?
Yes. If you multiply A times B first and then multiply by C, it is physically not the same result as multiplying A by the result of B times C.
So the groupings matter.
The order of operations fundamentally matters.
What does losing associativity mean for physics, though?
It implies that the order in which you measure or interact with the universe at that dimensional level fundamentally alters the structure of the space itself. It makes 8 an exceptional, rigid, hyper-constrained bottleneck in mathematical reality.
The documents also talk about a phenomenon called triality in 8 dimensions. What is triality?
Triality is arguably one of the most beautiful and bizarre symmetries in all of mathematics, and it only happens in exactly 8 dimensions. Nowhere else.
Why is it so bizarre?
Remember how we said earlier that in 3D classical spatial vectors and quantum spinors are related but fundamentally different objects? A coffee cup is a vector object. An electron is a spinor object.
Right, one takes 360 degrees to rotate, the other takes 720.
In 8 dimensions, the unique symmetry group called spin possesses triality. It means that the mathematical representation of a spatial vector, a left-handed quantum spinor and a right-handed quantum spinor, become perfectly flawlessly interchangeable.
They become the exact same thing.
They map onto each other completely. You can rotate equations representing space into equations representing quantum spin, and the math doesn't even notice.
That is insane.
The strict distinction between physical space, the vectors, and the quantum object spinning inside that space, the spinors, collapses entirely. They merge into a single, higher, unified symmetry.
Here's where it gets really interesting for me, because we've been talking about abstract algebra, but this number 8 physically crystallizes as something called the E8 lattice.
Yes, the E8 lattice.
Huh.
To understand this, we have to talk about sphere packing.
Okay.
Imagine a greengrocer trying to stack oranges in a pyramid so they take up the least amount of space. In 1D, a coin touches exactly two other coins.
Right, one on each side.
In 2D, a flat table, a penny can be surrounded by exactly 6 other pennies in a hexagon. In 3D space, a sphere can be touched by exactly 12 other spheres at once.
The kissing number problem.
Exactly. As you go up in dimensions, the packing gets incredibly complex and messy. Mathematicians struggled for centuries to find the absolute densest way to pack spheres in higher dimensions. And what happens at dimension 8?
When you hit 8 dimensions, something miraculous happens. The spheres snap into a perfect, flawless, unique arrangement called the E8 lattice. In 8 dimensions, one sphere touches exactly 240 other spheres.
240 spheres.
It represents a local maximum of geometric closure. At dimension 8, rotational harmony, quantum spinor algebra, and dense physical packing all lock together into a single optimal configuration.
It is like a liquid freezing into a perfect block of ice. Symmetry isn't just things looking the same on both sides. Symmetry is a process of mathematical possibilities freezing into highly specific, globally organized structures as you move up these dimensional ladders.
That is a brilliant way to frame it.
The chaotic freedom is stripped away, and you are left with the perfect crystal.
That analogy captures the exact essence of the paper. Symmetry is the progressive closure of structural degrees of freedom. At level 1, the number 2, we froze polarity. At level 2, the number 3, we froze spatial rotation. At level 3, the number 8, we froze algebraic division and local packing. Which brings us to the final ultimate level of the ladder. Level 4, lattice modular closure, the number 24.
If 8 is the peak of local algebraic organization, 24 is the threshold of maximal global organization. In mathematics, there is a very specific elite class of structures called positive, definite, even unimodular lattices.
That is quite the mouthful.
It is. And the rules of mathematics dictate they can only exist in dimensions that are divisible by 8. So 8, 16, 24, 32. But dimension 24 is where an absolute explosion of geometric richness occurs.
The source mentions the Niemeyer lattices.
Yes, in 16 dimensions, there are only 2 of these special lattices. But when you hit 24 dimensions, there are exactly 24 of these Niemeyer lattices.
24 lattices in 24 dimensions.
Yes, and they all culminate in one specific legendary structure, the Leech lattice.
Why is the Leech lattice so special? Why does 24 dimensions allow for a unique geometric harmony that, say, 23 or 25 do not?
The Leech lattice is a unique rootless lattice. It solves the sphere packing problem in 24 dimensions in a way that is so dense, so unbelievably symmetrical, that the spheres leave almost zero wasted space.
How dense are we talking?
Well, to give you an idea of the scale, in our 3D world, a sphere touches 12 others, right? In the 24-dimensional Leech lattice, every single sphere simultaneously touches exactly 196,560 other spheres.
196,560. The sheer scale of that organization is hard to fathom.
It is.
Yeah.
And its symmetry is so profound that it acts as the mathematical ceiling for numerous fields of physics. The document links 24 to some incredibly deep phenomena.
Like what?
In string theory, the math requires exactly 24 transverse dimensions to cancel out quantum anomalies, to make the equations function without producing infinite impossible results.
Wow, so string theory depends on 24.
Yes. 24 is also deeply tied to modular forms in number theory, and it is the bedrock for something called monstrous moonshine.
Monstrous moonshine. That sounds like a Prohibition-era drink for mathematicians.
Actually, a profound, almost spooky mathematical link discovered in the 1970s. It links the monster group, which is the absolute largest sporadic simple group in mathematics, representing enormous abstract symmetries and modular functions, which are deeply tied to 24-dimensional geometry.
And they found a link.
They found that the coefficients of these two totally unrelated fields matched perfectly. It was as if two distinct mathematical languages were telling the exact same 24-dimensional story.
So as we look at this entire ladder, why do these specific numbers, 2, 3, 8, 24, travel together? Why are they seemingly holding hands across the mathematical universe, dictating the structure of everything?
It is not a coincidence. They are linked by an underlying geometric chain, passing through what mathematicians call Hopf fibrations.
I saw that term. Can we break down a Hopf fibration?
A fibration is essentially a mathematical map that projects a higher dimensional surface down onto a lower dimensional one without tearing or breaking the geometry.
Like casting a shadow.
It is exactly like casting a shadow of a higher dimension into a lower one. And these specific Hopf fibrations only exist between very specific dimensions. The 3D sphere maps cleanly down to the 2D sphere via complex numbers. The 7D sphere maps down to the 4D sphere via quaternions. And the 15D sphere maps perfectly down to the 8D sphere via the octonions.
So there are literal mathematical bridges connecting these exceptional numbers.
Exactly. This recurring architecture of vibrations, quantum spin structures, and optimal sphere packings acts as a unified ladder. It represents the stages where the universe, or pure mathematics itself, reduces its degrees of freedom to become rigid, flawlessly stable, and globally organized.
Okay, let's take a deep breath, because we have journeyed a remarkably long way today.
We covered a massive amount of ground.
We started with the very concept of a boundary. We traveled through the quantum orbitals of an atom, through the crushing thermodynamic layers of the Earth's mantle, through the spectral energy equalizers of a chaotic waterfall.
Right across all the scales.
We proved that 3D space is the ultimate geometric Goldilocks zone, and watched as space itself bled off fractal tension to arrive there. And finally, we climbed an exceptional symmetry ladder all the way up into a 24-dimensional crystal sphere-packing lattice.
It is a profound, sweeping synthesis of how reality is structured.
And as a listener, if you are like me, you probably hate information overload. We live in a world drowning in isolated facts. But what we've discovered today is the ultimate shortcut. It is a single lens.
That is the best way to look at it.
By understanding this SO3 rotational backbone, the 2L plus 1 degeneracy ladder, and the symmetry closure, you don't have to learn chemistry, geology, and fluid dynamics as separate disconnected silos anymore.
You possess the master key.
Exactly. They're all just three-dimensional space expressing its own inherent, inescapable geometry.
And that is the true value of this kind of theoretical synthesis. Knowledge is most valuable when we connect the dots rather than just hoarding data.
I completely agree.
Critical thinking allows us to see these hidden unities. It enriches our understanding of the cosmos, moving us away from memorizing isolated trivia and towards appreciating the profound evolutionary architecture of mathematical possibility.
So as we wrap up this deep dive, I want to leave you with a final thought to mull over. A way to apply this abstract math to our actual lived reality. It is drawn from a tiny note in the source material on the closure interpretation.
A very interesting section.
We learned today that an atomic electron shell is a state of full closure. The energy is completely locked and quantized, perfectly stable and discrete. The math has frozen into ice.
Right, it is stable.
But we also learned that turbulence in a fluid, a rushing waterfall, is a state of partial closure. The energy hasn't settled.
It is still moving.
The spectral shells are transient. They are constantly evolving, exchanging energy from big eddies to small eddies, desperately trying to find mathematical balance.
Exactly.
If we apply this universal pattern to the macroscopic systems we interact with every day, the systems in our own lives, our societies, our economies, our political structures, they often feel like turbulence.
They certainly do.
They feel like spilled milk and chaos. But maybe our turbulent, chaotic human systems aren't just random noise. Maybe they are simply systems in partial closure.
That is a fascinating perspective.
They are chaotic eddies waiting for the right structural closure projection to finally snap into a stable, harmonious hierarchy.
It is a beautiful and strangely comforting thought. Chaos is just symmetry waiting to freeze.
Exactly. The universe inherently wants to find balance. Keep looking for those patterns. Keep questioning the borders that people try to put around knowledge, and keep digging deep.